Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for class 12 of CBSE as usual. The first problem meant for today goes like this. Evaluate integral x dx by x plus 1 into x minus 3 into x minus 7. I'll move on to the answer directly. I'm not going to write the question again. It comes under partial fraction. Let x divided by x plus 1 into x minus 3 into x minus 7 to be is equal to a by x plus 1 plus b by x minus 3 plus c by x minus 7. After taking LCM and cancelling out the denominator, I end up with x is equal to a into x minus 3 into x minus 7. I should multiply these two and divide these two here. And plus, of course, plus b into x plus 1 into x minus 7 plus c into x plus 1 into x minus 3. The denominator anyway gets cancelled. Now substitute x is equal to minus 1 in 1. What do I get? Minus 1 is equal to a into minus 4 into minus 8 plus 0 plus 0. B into 0 is 0, C into 0 is 0. Therefore, A happens to be 1 by 32. Now, substitute x is equal to, of course, minus 3 in 1. Sorry, plus 3 in 1, x minus 3, no? Therefore, 3 in 1, we get, what do I get? 3 is equal to 0 plus b into 4 into minus 4 plus 0. Therefore, I end up with b happens to be minus 3 by 16. B happens to be, if it is not clear at the bottom, I'll write over here, minus 3 by 16. Now substitute x is equal to 7 in 1. We get, what do I get? 7 will be is equal to 0 plus c into 8 into 4. Therefore, c happens to be 7 by 32. Therefore, the whole integral now becomes x dx by x plus 1 into x minus 3 into x minus 7. My value of a is 1 by 32. Sorry, minus 1 by 32. Sorry, there are three negative signs here. Minus 1 by 32. I corrected here anyway. Integral, I'll write it as d of x plus 1 by x plus 1. Then of course my value of b is minus 3 by 16. Integral d of x minus 3 by x minus 3. Then of course plus 7 by 32. Integral d of x minus 7 by x minus 7. Everything comes under dt by t format. Therefore it will be minus 1 by 32 log mod x plus 1 minus 3 by 16 log mod x minus 3 plus 7 by 32 log mod x minus 7 plus c will be the final answer. Let me just repeat the whole process. I will just explain once again. See here, it's application of partial fraction. The whole rational expression becomes a by the first linear expression plus b by the second linear expression plus c by the third linear expression. After taking LCM and cancelling out the denominator, I end up with x equal to a into x minus 3 into x minus 7 plus b into x plus 1 into x minus 7 plus c into x plus 1 into x minus 3. Substitute x equal to minus 1 in 1. Remember carefully, minus 1 is equal to a into minus 4 into minus 8 plus 0 plus 0. b into 0 is 0, c into 0 is 0. A becomes minus 1 by 32. By mistake I wrote 1 by 32, I corrected anyway. There are three negative signs. Minus 1 minus 3 is minus 4, minus 1 minus 1 is minus 8. It's correct. Substitute x equal to 3. 3 is equal to, here 0, here 3 plus 1 is 4, 3 minus 7 is minus 4. Now for b becomes minus 3 by 16. C into 0 is 0. Substitute x equal to 7. 7 is equal to 0 plus 0, c into 8 into 4. 7 plus 1, 8, 7 minus 3, 4. C becomes 7 by 32. Therefore, the whole integral now becomes minus 1 by 32 dx by x plus 1 can be written as d of x plus 1 x plus 1, so that it's of the form dt by t minus 3 by 16 integral d of x minus 3 by x minus 3 plus 7 by 32 into d of x minus 7 by x minus 7. Okay, this is plus 7 by 32, this is minus x minus 3. Therefore everywhere I have log. Now minus 1 by 32 log mod x plus 1 minus 3 by 16 log mod x minus 3 plus 7 by 32 log mod x minus 7 plus c will be the final answer. Therefore it is just a simple application of partial fractions. If you remember how to get the values of ABC and then proceed, it will be always easier. It will be always easier. It's not a difficult task, but remember one thing carefully. If anybody goes wrong in the calculation of ABC, they will not give marks for integral part in your board examination. Actually, you can even take it for granted. It's a question on partial fractions more than integration. Integration is there only at the end for 3 steps. For in the application of partial fractions, the ABC, any of the values happens to be wrong, the teacher may not give you marks in the board exam. Remember carefully. Then next one, find the area of the smaller region bounded by x square plus y square equal to a square, x plus y is equal to a greater than 0 using integration. See the question if you want. Now let me draw the diagram initially. Okay, let me explain the diagram. X square plus y square equal to a square is the circle with center 0, 0 and passing through a, 0, minus a, 0, 0, a, 0, minus a, and it is symmetric with respect to both the axes. Symmetric with respect to both the axes. X plus y is equal to a is the straight line. Passing through a, 0, 0, a. You can just draw the diagram. This is the diagram I will have. This is my a, small a, 0. This is my b, 0, a. This is x dash o x. This is my circle. This is my minus a, 0. This is 0, minus a. This is the region for which I am supposed to find out the area. I have to use integration. Remember carefully. I write it as a greater than 0 in the question because I may not know if a is greater than 0, my point a, 0 is towards the right side of the origin. That's the reason why I am mentioning specifically a greater than 0. Remember carefully. That's very, very important. Remember carefully. Okay. I repeat the diagram part again. X square plus y square into a square is a standard circle with center 0, 0 and radius a units. Radius a units can be written. I haven't written anyway. If you want, you can write that also. And it passes when y is 0, x is plus or minus a. Passes through a 0, minus a 0. When x is 0, y is plus or minus a. 0 a, 0, minus a. When x is replaced by minus a, minus x, the equation remains the same. Therefore, it's symmetric with respect to y axis. When y is replaced by minus y, equation remains the same. Therefore, it is symmetric with respect to x axis. Now, when y is 0, x is a. When x is 0, y is a. Therefore, it's a straight line passing through a, 0, 0, a. Therefore, from the diagram, I will mark one more point over here, C. From the diagram, you need not solve. From the diagram itself, I'll be able to get. From the diagram, we get circle and line intersect at a, small a, 0, b, 0, a. These are the 2 points of intersection of the given circle and the given line. Now, required area. There are 2 areas. It's a smaller area, it's a greater area. But specifically given, find the smaller area. Therefore, required area is equal to shaded area. See, you have to shade the portion, otherwise you will be losing step marks in the board exam. Now this is area OACB minus area of triangle OAB. That is area below the circle. See here, area below the circle minus area below the straight line. Only for this part, I am not supposed to apply half into OA into OB. I should not apply that. Remember carefully. This will be integral 0 to A. Y here is root of A square minus S square dx minus integral 0 to A. The y here will be A minus x dx. Let me apply the formula. X by 2 root of A square minus x square plus A square by 2 sine inverse x by A. It's a direct formula. 0 to A minus ax minus x square by 2 0 to A. Therefore apply upper limit plus A square by 2 sine inverse 1 minus 0 minus this is A square minus A square by 2 minus 0. Therefore this will get reduced to A square by 2 into pi by 2 minus A square by 2. Take A square by 2 as common. Pi by 2 minus 1. Therefore let me give the final answer here. A square by 4 into pi minus 2 square units. Okay, A square by 4 pi minus 2 square units, or if it is not visible, I will write over here. A square by 2 by 4 into pi minus 2 square units. Final answer I am writing at the top. It just may not be visible at times, the lower part. I will just explain the whole lot. The area part, required area, it's a shaded area. Area OACB minus area of triangle OAB. Now for the second part also I should use only integration. Being right angle triangle, I should not write half into A directly. I should not do so. Remember carefully. I have to use integration fully. For 0 to A, root of A square minus x square, because y is root of A square minus x square from here. Then here y is A minus x from here. Now for x by 2 root of A square minus x square plus A square by 2 sine inverse x by A 0 to A. It's a formula. Minus AX minus x square by 2 0 to A. A square minus A square is 0. A square by 2 sine inverse A by A is sine inverse 1. Minus 0 into anything is 0. Sine inverse 0 is 0. Here A square minus A square by 2 minus 0. Sine inverse 1 is pi by 2. Take A square by 2 as common. And after taking LCM, it gets reduced to A square by 4 into pi minus 2 square units. And this is only a generalized case. If the question is, let us say, given as x plus y is equal to 5, x square plus y square equal to 25, my answer will be 25 by 4 into pi minus 2. If it is x plus y is equal to 10, x square plus y square equal to 100, my answer will be 100 by 4 into pi minus 2. That will help you to put a tick mark in competitive examinations quickly and verify the answer in CBSE after doing everything systematically like this. I think you are able to follow. If it is general possibility x square plus y square equal to a square and x plus y is equal to a, my answer becomes a square by 4 into pi minus 2. If it is x square plus y square equal to 36, x plus y is equal to 6, my a is 6. So 36 by 4 pi minus 2, that is 9 into pi minus 2, that will be the final answer. If it is x square plus y square equal to 144, x plus y equal to 12, it is 144 by 4 into pi minus 2. Therefore, according to the value of a, you can have infinitely many such possibilities. Rest of the things will go as it is. Instead of a, I have 0 to 6, 0 to pi by 12, 0 to 6, something like that, 0 to 5. Accordingly, it varies. And you can verify the final answer in CBSE after doing like this. And you can put a tick mark in competitive examinations if you remember the final rule, common rule behind this particular problem. I'll check for an answer as usual. If there is any correction, I'll upload with the corrections. Otherwise, I'll upload as it is. Thank you, students, for patient watching.